Today, I'm excited to share with you the findings from my capstone project under the guidance of Dr. Danijela. And the topic of my capstone is the urban forestry and energy efficiency on school buildings, based on the case study in Waterloo's public schools. And the first part is the introduction, because I want to show you the relationship between the tree species, canopy cover, and their impact on energy consumption within school buildings. Urbanization and climate change are reshaping our living spaces, and the role of urban forests is becoming more and more important. My classmates have been talking a lot about the urban forestry today, so I will just briefly repeat it, and here are some examples of the benefits, especially for the school students. And first is the mental health. Some studies have shown that green plants, especially trees, has a positive effect on our mental health, reducing stress and improving concentration and mood of the students. And then is the environmental improvement. Trees can improve the environment of the campus by providing shade and reducing the heat island effect, which is essential for improving the comfort of the learning and teaching space. And third, of course, is the air quality, because the leaves from the tree can absorb the carbon dioxide and release the oxygen. By examining data on trees around the school buildings, I measured the canopy cover of each school and investigate the impact of these green spaces on energy efficiency in schools. I will also propose management strategies for optimizing green space. This is the study area, the Waterloo region. The tree data I use is from the Waterloo Region School Board. It is a nice and diverse organization that combines urban and rural area. It serves the three major cities of Waterloo region: Kitchener, the center of culture and commerce, and then is Waterloo, the city of education and technology center. And then is Cambridge. It is famous for its historical architecture and natural scenery. And there are 122 public schools in WRDSB in total, and 77 school properties with neighborhood inventory are used for analysis as my sample. We can see that a lot of the public schools are located at the rural area, like in the Linwood or the Wesley, but most of them are still located at the center of the city. Here are the two research questions of my capstone. First is, how do various tree species and canopy cover affect energy efficiency in school buildings? And second, how can these trees be managed more efficiently? And then I will show you the method I use. A cornerstone of my research is the tree inventory. Use the neighborhood protocol, which captures the data on tree species, tree size, health conditioning, and confliction to the school buildings. Then I put the data in GIS. Each tree's distance and directions to the nearest building are measured, because understanding this spatial relationship is critical to accurately measure the building energy usage in iTree. The final step was to integrate and analysis the data using R, a powerful tool for statistical computation. This allowed me to get nice graph and test meaningful correlations between canopy cover, energy savings, and some other parameters, like carbon emission reductions. Then I will show you some results from my capstone. The overall findings is that there are 4,267 trees in total. On average, there are 55 trees per school, range from only 8 trees in one school to 136 trees. And we can see the table on the right. The most dominant species are the Norway maple, red maple, and Norway spruce. They made up about 50% of the total leaf area. And the IV stands for the importance value. It is calculated for the species who play a very important role in urban forest structure. There was a notable variation in tree canopy cover across the schools, ranging from less than 5% to over 20%. And this highlights the disparity in green coverage among the different schools. And the average tree canopy cover per school is 8.5%. We can see that the darker green means the higher canopy cover percentage. And there's also an interesting finding that Cambridge has a lower canopy cover percentage. However, the Waterloo has the highest canopy cover percentage. I introduced a new concept, the overlap area. This parameter measures how much a tree's canopy overlap with the school building. This helps in understanding the extent of shading provided by trees and its impact on building's energy consumption. Meanwhile, I will weigh the pros and cons of the building and tree conflicts later. And we can see that the area over the building is 28.6 meters square on average. And the green circle means is the tree canopy, and the blue area is the overlap area. My study from iTree shows that larger canopy areas reduce carbon emissions more efficiently and require less energy for cooling. This was supported by statistical analysis showing the positive correlation between canopy cover and carbon avoidance, and heating and cooling impacts. Look at this. Both European beech and American beech emerged as particularly effective in carbon emission reduction and energy conservation. Although I mentioned that the Norway maple is the dominant species, but it did not highly influence the school energy saving due to its spatial isolation from buildings. Here are some recommendations. And this is the example of one of the public school. There are 31 trees within less than 90 meters of the building, and these trees represent approximately 25% of the total trees in school. Most of trees are concentrated in the southwestern part of the building, so I think this tree planting for energy saving can be designed. This is really a good example. This colorful circle means different tree species that has a higher influence to the energy saving. And I must repeat again that some schools have as much as 20% canopy cover, and the confliction should be noticed. When trees are close to school buildings and have a confliction, environmental benefits and building safety threats should be considered at the same time. The shade provided by trees can lower temperature inside buildings, like reducing energy consumption, improve air quality. However, trees can also cause damage to buildings, such as root damage to ground or branch damage to building structure, and even threaten the students' safety during some extreme weather, like storm or some heavy rain. My study still have some limitations. First, the scope of the study was limited mainly to the Waterloo region. This means the conclusions drawn may not apply to other regions or other building types. Second, the accuracy of the data is not perfect, and the GPS position error is 3 meters. And the energy data used is the default data from iTree. I think this is a very limited error for me. And finally, from the higher perspective, urban forestry is a complex adaptive system that interacts with a wide range of the environmental, economic, and social aspects, and it may be challenging to capture all the details by current research methods. And I really want to acknowledge the contribution of the Dr. Danijela, who is my supervisor, for her patience and detailed guidance. And I also want to express my gratitude to my external supervisor, Levi, who really helped me a lot.